Yes, so that's why variable has to take that. C belongs to R, C less than 1. Okay, if C less than 1 means it represents below all numbers, which is below 1. Okay, so that's why below 1, here no need to find left limit and right limit. Why? Because it's not changing. So this is limit value and function value f of c. F of c is equal to c plus 2. So limit value equal to function value. Therefore, f is continuous for all less than 1. F is continuous. F is continuous for all x less than 1. Go for next. Fx is greater than 1. Above 1. Above 1, any number you can take it. 2, 3, 4. Instead of that, take the variable constant. Variable number. Let A belongs to R, which is A greater than 1. Now, limit x tends to A, f of x. Here, no need to find left limit and right limit because it's not changing. Limit of x tends to A, f of x. Above 1, f of x is x minus 2. Then which is equal to A minus 2. Then function value also f of a equal to a minus 2. So limit value equal to function value. Therefore f is continuous. F is continuous for x greater than 1. So f is continuous every way except 1. This is the way to find the continuity, to check the continuity. So here the question is, what the question is? Find all the points of discontinuity. Okay, at what point discontinuity? 1. Discontinuity means not continuous. Okay. Every polynomial function is continuous. So that every polynomial function is continuous. This is polynomial function. Tell me the polynomial function. F of x equal to x square. Is it polynomial? Yes. F of x is equal to x plus 3. Also polynomial. Degree is 1. So what is the general form of polynomial? F of x is equal to a naught. Constant also polynomial. Constant also polynomial. So which is called constant polynomial. So the polynomial general form is f of x equal to a naught plus a1x plus a2x square plus a3x cube plus so on an x raised to n. So this is the polynomial function general form, which is having degree n. If degree 2, quadratic equation. If degree 3, cubic equation. If degree 1, linear polynomial. If degree 0, constant function. Okay. Now this is the polynomial function. Okay. So let's verify whether it is continuous or not. Okay. A0, A1, A2, A3, An. Those are constants, which is belongs to the real numbers. Okay. Take any point at x is equal to c. X is equal to c, where c belongs to real number. Any point. It may be 0, 1, 1.1, 1.2, minus 1, minus 2, minus 3. Any number. C belongs to R. So it's true for all numbers. Okay. X is equal to c, where c belongs to R. Okay. At this point, we should find limit. So this function, is it changing at the point c? No. So no need to find left limit and right limit. You can find direct limit value. Limit of x tends to c f of x. Limit of x tends to c f of x a naught plus a1x plus a2x square plus so on an x raised to n. Put x is equal to c here. A naught plus a1c plus a2c square plus so on an c raised to n. So this is limit value. Next function value f of c. X replaced by c. A naught plus a1c plus a2c square plus so on an c raised to n. This is and this is both are same. Therefore limit x tends to c f of x equal to f of c. So limit value equal to function value. Therefore, f is continuous. F is continuous at x equal to c, where c belongs to real number. That means f is continuous everywhere. What is the f? Here f is polynomial function. So every polynomial function is continuous everywhere. Understood? Every polynomial function is continuous. For example, f of x is equal to 3x plus 2. Tell me, is it continuous or not? Yes. Why? Because which is polynomial. Every polynomial function continuous everywhere. Okay? So this, by saying this, it's a polynomial, therefore it is continuous. Okay? F of x is equal to x plus 5, also polynomial, then continuous. F of x is equal to x square plus 2x plus 3 is also continuous because polynomial. F of x is equal to x, also continuous. It's a degree 1. Okay? F of x is equal to 5, also continuous because this is constant, also polynomial. Like every polynomial function is continuous. This is theorem. You can consider theorem. Okay. If any way while finding polynomial is there, no need to find that. You can write limit and limit value function value. No need to find. Just if it is polynomial, you write it. Every polynomial function is continuous. Therefore, this is polynomial. Then it is continuous everywhere. Okay. Just now we have discussed the mod x. See. Equal to x when x is greater than 0, when x is less than 0 minus x. At 0 we have checked already, left limit and right limit because it's changing. But other than 0, if x is greater than 0, f of x equal to x. What is this? Polynomial. So which is polynomial? Therefore every polynomial function is continuous. Therefore, this is mod x is continuous for all x 0. Like this. If x less than 0, f of x is equal to minus x, which is also polynomial. So every polynomial function is continuous. Therefore, it is mod x is continuous for all x 0. Like this. Understood? So we can consider this standard point. One more question. Discuss the continuity. Of the function defined by f of x equals x plus 2 if x less than 0, minus x plus 2 if x is greater than 0. Right? At what point it is changing? 0. At what point it is changing? 0. Right? 0 is not in the domain. We are equal 0, they are not given. Equal, they are not given. Equal, for example, equal. X is equal to 0 is a 1. X is equal to 1. So at what point changing? At 0. Okay. First, at x is equal to 0, find the limit. First, let's find left limit. Limit of x tends to 0 minus f of x. Limit of x tends to below 0. Tell me below 0 is x plus 2. Put x is equal to 0. 0 plus 2 equal to 2. Right limit RHL, limit of x tends to 0 plus f of x, limit of x tends to above 0 minus x plus 2. For 0 plus 2 equal to 2. So left limit and right limit equal. Right? So limit exists here. What is the left limit here? Limit of x tends to 0 f of x equal to 2. But function value f of 0, tell me f of 0. At 0, f of 0 is 1. So limit value not equal to function value. So limit of x tends to 0, f of x not equal to f of 0. Therefore limit value not equal to f of 0 means f is not continuous. F is not continuous at what point? X equal to 0. F is not continuous at x equal to 0. Understood? Next, other than 0, below 0 if you take. If x is less than 0, tell me f of x is equal to x plus 2. Tell me how to check the continuity of this. So x plus 2 means polynomial. So which is polynomial? Which is polynomial? Every polynomial, we know that every polynomial function is continuous. Every polynomial function is continuous. Therefore, f is continuous at x less than 0. Next case, if x is greater than 0, tell me if x is greater than 0, f of x is equal to minus x plus 2. Okay, which is also polynomial. Therefore, every polynomial is continuous. Therefore, f is continuous for at x greater than 0. Tell me the conclusion is f is continuous for all above 0, f is continuous for all less than 0, but f is not continuous at 0. Tell me f is continuous. F is continuous all real number except 0. Except 0. If it is, there is no 0 here. If x is equal to 0, for example 2, then f of 0 is 2. Then left limit and right limit equal. Therefore it is continuous. Therefore f is continuous everywhere. Okay. If x equal to 0 not there, then what? Only limit exists here. Okay, but function value we don't know here. At 0, what is the function value? Don't know. So 0 is not there in the domain. 0 is not there in the domain. When the 0 function value is not given, don't find function value at that point. You find other than that. Not 0, below 0 and above 0 only you should find. For all below 0, which is polynomial. For all above 0, which is polynomial. Therefore it is continuous everywhere. In the domain of f. In the domain of f. In the domain of, what is the domain of f? All real number except 0. What is the domain of f? Domain of f is, tell me, all real number except 0. So at 0 we are not, because 0 they are not given, so we can't find that. So except 0 we can find, except 0 it is continuous. So in that domain it is continuous. In this domain, if not 0 given. Okay? If 0 given, if 1 given, not continuous. Because left limit, right limit is 2, function value is 1. If it is 2, continuous everywhere. If it is 3, not continuous. Like that. One more problem. Exercise 5.1. Exercise 5.1. Textbook. Page number 159. The question number 6. Find all points. Discontinuity of f. Where f is defined by f of x equal to 2x plus 3 if x less than or equal to 2. 2x minus 3 if x greater than 2. We have discussed the continuity of f. Tell me, by seeing this function, f is changing at what point? F is changing at what point? X equal to 2. So then we should find left limit and right limit. LHL. LHL. Limit of x tends to 2 minus f of x. Limit of x tends to below 2. 2x plus 3. For x equal to here, 2 into 2, 4 plus 3, which is equal to 7. Right limit, limit of x tends to 2 plus f of x. Limit of x tends to above 2, 2x minus 3. For x equal to 2 into 4 minus 3 equal to 1. So left limit not equal to right limit. Therefore limit x tends to 1 f of x, x tends to 2 f of x does not exist. Therefore f is not continuous. F is not continuous at x is equal to 2. Okay, we have checked the continuity at what point? 2. That means f is discontinuous. Not continuous means discontinuous. So f is discontinuous. F is discontinuous at x is equal to 2. Right? Next case, below 2. If x less than 2, tell me f of x equal to 2x plus 3. 2x plus 3. Which is polynomial. So every polynomial function is continuous. Therefore f is continuous. F is continuous at x less than 2. Case 2. If x is greater than 2, f of x equal to, tell me, 2x minus 3. Then which is also polynomial. So every polynomial function is same repeat here. Every polynomial function is continuous. Therefore f is continuous at x greater than 2. Tell me, what is the question? Find all discontinuity point. For all less than 2 continuous, for all above 2 continuous, at what point discontinuity? 2. Here fail. Therefore f is discontinuous. F is discontinuous at x is equal to 2. Tell me, f is continuous at what point? F is continuous at all real number except 2. Okay, this we can find by graph method also. If you draw the graph, at 2 you will get break. Other than 2, there is no break. See, if you draw graph like this, 0, 1, 2, minus 1, minus 2. F of 0, 2 into 2, 4. 4 plus 3, 7. Let us see here, 7. Below 2, above 2. If you take 1.9 here, 7 comes. If you take here 2 into 4, 4 minus 3, 1. 1 comes. Right neighborhood, if you take 1, left neighborhood is this. So you will get like this. If you take 0, 0 plus 3, 3. Means you will get like this. Above 3, if you take 6 minus 3, 3. Increasing like this. So the graph has a break at what point? 2. Above 2, no break. Below 2, no break. At 2, it has a break. Therefore, it is discontinuous at what point? 2. Understood?
One more, the question number 7.
Find the discontinuity f of x equals mod x plus 3 if x less than or equal to minus 3, minus 2x if minus 3 less than x less than 3, 6x plus 2 if x greater than or equal to 3. Here there are, tell me how many changing points are there? This function is changing at what point? Minus 3 and plus 3. There are 2 points. Okay, this question you can practice today. We'll discuss tomorrow.